Hey there, Grade 7. Welcome to today's Explainer. I am absolutely thrilled to be guiding you through this because we are kicking off a truly critical phase of our Unit 5 journey into Python loops. Now, before we can jump in and start writing incredible code that repeats tasks automatically, we need to talk about the builder's workflow. So today's goal? We are going to expertly set up your development environment so you are completely prepared to tackle your application task. Think of it kind of like organizing your digital workbench before you start assembling all the pieces.
So, this brings us to a really important guiding question, just to get our minds working. How do we safely build and test our Python loops? I mean, think about it. If you were building a delicate scale model, you wouldn't just glue the pieces together right on your kitchen table right before dinner, right? No way. You'd set up a dedicated, safe workspace. Well, code is the exact same way. We need a proper environment to ensure our loop application runs perfectly, without messing up literally anything else on our computer.
Okay, let's dive into this. Here is our roadmap for today. 1. Application task setup overview. 2. Creating your safe workspace. 3. Starting the Python interpreter. 4. Building the loop application. 5. Quick task knowledge check. And finally 6. Application task final takeaway.
All right, Section 1, Application Task Setup Overview, because every great builder needs to understand the purpose of their tools and workspace first. Let's establish a really clear claim right off the bat. We absolutely must use what is called a virtual environment for our projects. You might be wondering, why? Well, let's look at the evidence. Python applications often use modules that don't come as part of the standard library. So if we just install everything globally on our main computer, we run into a major problem. Imagine application A needs version 1.0 of a particular module, but application B needs version 2.0. If you install either 1.0 or 2.0 globally, the requirements are going to be in conflict. The reasoning here is simple, but it is critical. That conflict will literally leave one of those applications unable to run. It's like a giant puzzle where the pieces just don't fit. The solution? A virtual environment. It's a self-contained directory tree that keeps application A's tools totally separate from application B's tools. That way, they both run safely.
Moving right along to Section 2, creating your safe workspace. Now that we know the why, it is time to actually build that self-contained directory, which we call a VNV. And this brilliantly illustrates how simple it actually is. Here are the exact 2 steps you need. Step 1 creates the environment. You just run python-m VNV tutorial env. This tells the VNV module to create a brand new directory containing its very own copy of the Python interpreter and all its supporting files. Then step 2 actually turns it on. If you're on Windows, you'll run tutorial-env/scripts/activate. And boom, just like that, your safe, isolated digital workbench is officially open for business. Now, we do need to pause for a quick boundary check here, because understanding the limits of our tools is absolutely key. When you activate that environment, 2 things happen. It modifies your shell prompt so you can visibly see you're inside it, and it ensures you are using that specific Python installation. But here is the critical limitation you need to remember. Activating the virtual environment does not alter the Python path variable in any way. If that path includes references to incompatible code from outside your workspace, you might get some really weird, unexpected results. It's kind of like trying to use a metric wrench on an imperial bolt. It's just a great reminder that while virtual environments are super powerful, we have to remain aware of how our shell paths are set up. All right, Section 3, starting the Python interpreter. With our safe workspace fully prepped, we can finally pick up our main tool. To actually invoke the interpreter within your newly activated environment, you just use the command python 3.14. This simple command tells the computer to start the Python engine so we can begin feeding it our loop instructions. So the crucial point is this. When you run that command, the interpreter operates interactively. You'll know it's working when you see that primary prompt, those 3 little greater than signs staring right back at you. That means the interpreter is officially in interactive mode. It's basically like a chat window with your computer, patiently waiting, totally ready for whatever instructions you give it next. Which brings us to Section 4, building the loop application. The workbench is clean, the interpreter is waiting. Let's prototype our very first loop. But before we write the loop, we kind of have to know what a loop actually acts upon, right? In Python, a for statement needs what we call an iterable. Straight from the Python documentation, an iterable is an object suitable as a target for functions and constructs that expect something from which they can obtain successive items until the supply is exhausted. Now, in simpler terms, it is just a sequence of items that we can go through one by one. Now, what's really interesting here is how elegant Python makes this. Instead of defining complicated iteration steps and halting conditions like you have to do in older languages, Python's for statement simply iterates over the items of any sequence. Boom, done. Here we're using the built-in range function to generate our arithmetic progression. You just type for I in range 5, hit enter, make sure you're indented on the next line, and type print I.
But wait a second. We absolutely need to address a very common beginner misconception right here. When we look at the limitations of the range function, we see it generates an arithmetic progression that starts at 0 by default. But crucially, the given endpoint is never, I repeat, never, part of the generated sequence. So range 5 will output 0, 1, 2, 3, and 4. It will never output the number 5. The loop stops just before it hits that boundary.
Okay, section 5, quick task knowledge check. Let's briefly test your memory before you go do the actual application task yourself. Here is a quick retrieval check for you. Based on the endpoint boundary rule we literally just learned for the range function, how do we write a sequence that generates exactly 10 values? Think about how that endpoint limitation actually works. I'll give you a second.
Did you guess range 10? Because if you did, you are absolutely correct. Remember, because it starts at 0 by default and the endpoint is always omitted, range 10 generates exactly 10 values, 0 through 9. Those are the legal indices for items of a sequence of length 10. Mastering this little detail right now is going to save you so many debugging headaches down the road, for sure.
Let's move to section 6, application task final takeaway, and see how this all builds together. You now have the exact workflow to set up your isolated virtual environment, plus the foundational knowledge of how a for loop grabs successive items from an iterable. So I want to leave you with this final provocative thought. Drawn right from the source text, Python's for statement iterates over the items of any sequence. Your environment is ready. Your interpreter is waiting in interactive mode. The only question left is, what sequence will you iterate over in your Unit 5 application task today? Go fire up those virtual environments, start coding those loops, and honestly, I can't wait to see what you build.